Question A, it says determine an equation of the inverse of y equals negative x squared plus 4, and then in B, sketch the graph. Okay, so we're going to still use the big idea here that if you want an inverse, you have to switch x and y. So if I want an equation of an inverse, I switch x and y. Now technically, this is an equation. You would be basically done, but usually after we switch x and y, then the next thing we try to do to find out its graph is we try to solve for y, which is the activity we did at the end of class yesterday. Can you get y by itself? So I would first move the 4 over to the other side by subtracting 4 on both sides. Then I could divide both sides by negative 2. And finally, if I have y squared by itself, if I wanted to get y by itself, I would square root. Question? There's no 2? I just made up a 2? Wow, that's impressive. You're right. Okay, I'm so sorry. This 2 is just made up. So that makes our life a lot easier. I'm sorry. Another example of inability to copy. Oh no. Like, that's 3 times? Might be a worse issue than I had originally thought. Okay. So then, if we have just the negative y squared instead of a negative 2y squared, we could either divide by a negative 1 or multiply by a negative 1 to get rid of that negative. I'm going to multiply this side by a negative to get rid of the negative. And then we get to the point where, how do you get rid of a squared? You square root, and you're going to have to remember a plus or a minus. Question?
Okay. Can you switch before you make, could you like do the, could you make x the subject of formula before you switch?
You could solve for x first and then switch after, yes. But generally, on the exam, how they mark it, sometimes they give you a full mark for switching x and y. So I like doing that first, because they'll give you a mark on your final exam. And then if you make algebra mistakes after that, they're going to ding you for that. If you try to solve for x first, make algebra mistakes, and then switch x and y when it no longer makes sense to switch, they might not give you as many marks. So I think it does make sense. And we'll try to switch our x and y first, and then solve for y. So here is the equation of the inverse, and it's got a plus or minus. Okay? Next, it says to sketch the graphs. Of y equals negative x squared plus 4 and the inverse. So I'm going to draw take your parabola. Are you okay that this is a regular parabola with a vertical reflection and then a vertical translation? So you imagine your regular parabola, flip it down, move it up 4. As you get really good at this, you'll be able to graph that quickly. It has a vertex at 0, 4. It goes through the point 1, 3 and 2, 0. Also negative 2, 0 and negative 1, 3. If you can draw the original graph, maybe I should have given myself more room, but I'm going to draw the inverse on a separate one. So my inverse graph I want to graph plus or minus the square root of negative x plus 4. I could use my skills with square root graphs and draw it. However, if you have the original graph, it is much easier to just switch x and y. So for example, I have 0, 4, switching x and y on my inverse, I would have 4, 0. Instead of 1, 3, I would have 3, 1. And instead of 2, 0, I'd have 0, 2. Similarly, I'd have these points. Okay. If you're graphing this as a square root, the plus or minus is actually in front 2 different graphs. One graph, slide up here, we can think of this as one graph is the plus, so negative x plus 4, and the other graph is the minus in front, negative x plus 4. What does the negative inside do to your graph? What kind of reflection? Horizontal. Can you see that the top part is a square root that's been flipped horizontally? The bottom part is a square root that has been flipped horizontally. The top part is the positive one. The bottom part also had your square root flipped down and flipped over. That's going to be the negative one. Okay? Which way did this actual graph get translated? 4 units to the right. X's are liars. Shouldn't we have a minus 4 in there? Why is there a plus 4?
What did you say?
I said that the final graph, that way I've drawn it, because I just took my original graph and switched x and y. And I said that's the easiest way to graph the inverse. But if we decided to graph it from the equation, this top part has been square root flipped over and then moved 4 to the right. And if x's are liars, isn't 4 to the right minus 4? Why does it have plus 4 in there? Sorry? It's just wrong? Or is this one is actually a hidden place where you haven't written it in factored form yet? See that factored form? How tricky that would be? That would be, if you're using transformations, even a negative out in front, a horizontal reflection, would have to be factored out. So now it matches up. This horizontal reflection, 4 to the right, that matches up with the top part. Vertical reflection, horizontal reflection, and 4 to the right, that matches up with the bottom part. But it's much easier to take the original graph and switch x and y. It is x minus, because I factored out the negative. Yeah. Okay. Part C here says, is the inverse a function? Is the green one a function? No. Green one is not a function because it doesn't pass the vertical line test. At the bottom of page 239, they have this question, and they ask, when is the inverse of a function also a function? have a horizontal line test. So when your original function passes a horizontal line test, you would know that your inverse will also be a function. So if we think back to the parabola that we just did, see if I can find it. There it is. Can you see if you drew a horizontal line on the blue one, you would hit 2 points? That means on your inverse, it will be a function. But if your original one passes both a vertical line test, because it makes a function, and a horizontal line test, then the inverse will also be a function. Functions are really important for math because we can't get computers and calculators to give us good answers if things aren't functions. Then your calculator won't function because it'll get confused. It'll be like, which answer do I give you? There's more than one right answer. And then it gets a little bit of a problem. And we've dealt with some of those problems in the past. Like in trigonometry, we run into that problem with the cast rule. Your calculator only tells you one answer. But then you would say, I also have to find the answer in quadrant 2 and quadrant 1. So we have some places where we need more than one answer, but our calculator, in order to function, it's been taught just to tell you one answer and not more than one answer.